Hello there, and then welcome to a brand new video. This is Hub Beyond Numbers. In this lesson, we are looking at scalar multiplication of vectors, and by the end of this lesson, you'll be able to understand what scalar multiplication of vectors means, apply it, and then also solve some real world problems as well. So without much ado, let's quickly look into it. So when we talk of scalar multiplication of vectors, let's take this example we have over here. So with this vector over here, which is a movement from A to B, you are doing this a particular number of times. So let's say you are moving from a particular point to the other, from A to B, and you have done that, as I've said, for a particular number of times. If you want your total displacement, then it is the number of times you have moved. So let's just say you have moved just twice. That is 2 times of this vector, you see. So this one plus itself again. You realize that it has moved from point A, and I can say it has come toward point C, whose coordinate is what? 7, 9, right? So scalar multiplication simply means you are increasing or decreasing the size of a vector by multiplying it by a number. That is all. That is all scalar multiplication of vectors is. And its mathematics is so simple, as you'll be seeing very soon, right? So let's say you have a vector v. So if vector v is equal to xy, and then you have a scalar. So let's just let our scalar be k. Okay, so this here is a vector and this is a scalar. Now the scalar can be any real number, either positive or negative, what have you. Then we would say that our k v is the what? A new vector that you obtain it by multiplying your scalar by your vector. You see, that is k into bracket x, y. Then how do we evaluate it? This scalar here multiplies the x component and it also multiplies the y component. Do not mistake this for fractions where it would have only multiplied the numerator. No. So for vectors, your scalar multiplies both components so that you get what? Kx and then ky. Let's look at how we can apply these concepts. So for our first question here, we have to multiply the vector. So this is our vector 2, 3 by a scalar 3. It is very simple. So we know our vector v is what? 2, 3, and then our scalar k is equal to 3. So if you want k v, then it is just what? The 3 multiplying 2, 3. You see, you can write it as 3, then 2, 3. And as I said, the 3 or your scalar multiplies the x component and it also multiplies your y component. So that I have what? 3 times 2 and then 3 times 3. And 3 times 2 gives us a 6. 3 times 3 gives us a 9. This here is your scalar multiplication. Let's solve one last example, after which I'll now give some questions that we can really apply in real world problems. Okay, so for this second question here, it says we have to do what? We have to multiply x5 by 4. You see, so in this case too, we apply the same concept here. You can pause and then try your hands on it and see. So our vector v is what? X5, and then our scalar k is 4. Hence, if you want k v, then that is 4 into bracket x5. And now 4, as I said, multiplies the x component and it also multiplies your y component, giving you 4x. Then 4 times 5 is what? 20. So this here would be our resultant vector after multiplying by the scalar. Now that we know the basis of multiplication of vectors by scalars, let's look at how we apply this concept in word problems. So looking at this word problem question here, it says what? A boat moves east with a velocity 50. If the engine power is doubled, you have to find its new velocity. You see, now this one here is just a simple question that applies what? Scalar multiplication. We know our vector is what? 50. That is the velocity of the boat. The engine power is doubled. This is the scale factor. You see, so our scalar then is what? 2. So if you want its new velocity, that is the new velocity is going to be the scalar that is doubling this old velocity here. So k v. And how do we solve it? So k v would then be equal to what? Our k, which is 2, times the velocity, which is 50. Simplifying, we have 2 times 5 and then 2 times 0. 2 times 5 gives us a 10, and 2 times 0 we have a 0. So the new velocity of the boat is going to be what? 10, 0. As simple as that. Let's look at one last question. But before that, this conclusion here is that the boat is moving in the same direction, but then now it is twice as fast. Remember, it was initially 5, but now it is 10 because of the doubling. So it is still going towards east, but then it is twice as fast as it was initially. So let's look at this question here. That will be our last question. And it says a drone flies in a direction represented by vector d, which is equal to 5, -2 for 10 seconds. Now, what is the position vector of the drone after 10 seconds? So the vector here is what? D. That is 5, -2. And we are saying that it is undergoing this movement for 10 good seconds. That will be our scalar. You see, so its position after 10 seconds. I don't know if I can draw this so that you visualize it. Okay, so if it is undergoing this movement for 10 seconds, then for every second, there would be an addition of what? 5, -2, 5, -2, 5, -2. So you are going to add 5, -2 10 times. That is if you want to apply vector addition. But if you want to apply scalar multiplication of vectors, all you need to do is to do what? Multiply your k by your vector. And our k is 10 multiplied by the vector 5, -2. Hence, evaluating it, we have 10 times 5 and then 10 times -2. And that gives us what? A 50, -20. And this here is the position vector of the drone after 10 seconds. You see, that is 50, -20. So that ends it for this session. We've spoken about scalar multiplication of vectors. In our next video, we'll be looking at dot product or dot multiplication of what? Vectors. So as usual, I'll leave you with these exercises here. They are just 5 in number, and you can try them just to test your understanding on scalar multiplication. Once again, this is how beyond numbers, where we learn maths the easy way. If there's any issue of concern, you can always let me know at the comment section. And if this is your first time, you can choose to subscribe if you so do wish, so that you receive notifications of all my lessons. I do hope this lesson has been a nice one. Stay blessed and see you in our next session. Bye for now.